So there's your typical crappy soldering iron, and with a tip of one, I will say. And people don't usually talk about this. This is actually from like my high school electronics teacher. But what you do is you pretty much never solder with this unless you really need a really sharp point. So the thing you would normally do is take something like a file, and you would actually file it into something that's more like, depending on what you're going for. Let me see if I could find the thing. You would use a file and file it into something more like either a... Oh, there we go. I'm trying to get it on the camera. Nope, that's not the thing I'm trying to get on the camera. There it is. I don't know if that's in focus or not.
You can see it. So like a 45-degree angle, sort of.
Yeah, this is like a chisel tip. So it's basically, you could either make it look like a small flathead screwdriver, like a little jeweler screwdriver, or, you know, something else. But just something, what you're going for is to get a little bit more surface area than you can get on the thing you're trying to solder. That just won't.
Yeah, that camera's been doing that. I don't know why.
Oh, okay. You want to get like a little more surface area and contact area of the thing you're trying to solder.
Kind of like the edge of an X-Acto.
Yeah. So if you look at like the PCB here, and if I was actually going to solder with this, I would actually be able to get, you know, come at it from the side and have a decent amount of surface area as opposed to just like a point touching it. Okay. So that just, you know, kind of sets the stage there. And I'm actually going to put that tip on this soldering station here. We're actually going to use this JVC solder station because
it's our very fancy, mostly overkill, expensive soldering station that we have. But
yeah, it is overkill, but it's for trying to do something on a camera where you basically don't have enough hands to like hold things and, you know, try to figure out where you're going to put down a soldering iron and not melt the IKEA table. I'm going to use this JVC solder station if it works. Come on. All right. While I'm firing this thing up, since I have to do a thing like setting temperature.
What temperature do you usually solder at for surface mount components? I've never really known this. I just kind of like put it at some temperature and kind of go.
Okay, so for soldering anything, you want to go at the lowest temperature possible and still have the solder melt.
Okay.
Okay. Now that, depending on what you're soldering, if the thing already has solder on it, like you're trying to remove a component, you don't know what they used when they made it. You don't know if it was silver solder, you don't know if it was what like kind of alloy solder they used. It varies, but typically it's around 380 degrees is when solder transitions from a solid to a liquid. It gets a little bit lower if you have what's called a eutectic alloy. Have you ever heard that term?
I have not.
You don't know what eutectic alloy is? Okay.
I do not.
This solder that we have here, the fancy solder that Ryan had with this solder thing, he bought the good stuff actually, unbeknownst to him maybe. He bought what's called 6337 solder. So your typical cheap solder you find like a Walmart soldering kit or whatever, just at the auto parts store, that will be what's called, it'll be like 60-40 solder.
Yeah.
That's just the ratio of tin and lead, right? Well, that ratio, if it's just 60-40, isn't a perfect ratio, which means that as it starts to cool, there's a few degrees during that cooling where it will go from a liquid to a plastic.
Huh.
And then it goes to a solid. It's like a plastic deform, like if you ever hear of a plastic deformation of metals and stuff, like the point where when you start bending a hanger and then it gets to that point where it's about to break, right? Where it's actually like, doesn't flex back anymore and stuff. Kind of the same thing, but it's for solder. And the really bad thing about the plastic region is that if you go to solder something and you're not holding everything perfectly together from moving, and it happens to move as the solder's cooling through that plastic region, then the solder joint looks dull and it's actually brittle. So that's bad, right? You don't want that. You can kind of cheat by getting the more expensive 6337 solder. That solder does not have a plastic region.
Huh. Okay.
So it just it just transitions from liquid right to the solid, and it should come out. Joints like that tend to come out. Solder joints like that come out much shinier. There's less chance of it, being a weak joint, anything like that. So it's one of those things, if you're buying, especially if you're just doing a little solder project, you're probably not spending that much in the first place because you're not buying that much solder. So
what's like the price? It's just a couple of bucks or something like that.
It's like 10 or 20% more expensive.
Okay,
basically. Yeah. It's not crazy, especially if you get into something like a 1 pound roll.
Yeah,
which is what this is. It adds up. If you might be spending, from $15 to $20 or something like that. But you get a 1 pound roll of solder, you're probably never going to buy a spool of solder ever again. We've made plenty of stuff on this, and I think, I don't know, it's like doesn't even look like it's come down at all. Another thing, if you're soldering stuff, you should probably have some isopropyl alcohol, and you should probably have some lint-free wipes. Not for cleaning the soldering iron tip, because that will start lighting things on fire. You don't want that. What you do want is to use isopropyl and lint-free wipes to actually clean the stuff you're going to use. So, for example, the solder itself. Because solder, the outside of solder actually corrodes, and it'll get some crap on it, just over time, just corrosion and stuff. So all you do is you just take the solder, you put it in like a taco lint-free wipe with some alcohol on it, run it through a few times, and then the solder comes out looking pretty darn shiny, actually. That's what you want it to look like. And then here's my other kind of cheat thing. This is all like prep stuff, but you take the solder and you wind it around your finger. I think Ken's seen me do this trick a few times.
Yeah.
You wind it around your finger and kind of make yourself a little bit of like a roll of solder. But the thing is, if you do it right, you got the other camera, Ken? Yeah. If you do it right, you don't need to... Why is this not showing up? If you do it right, you don't need to hold the solder. You just, have it on your finger.
Now that seems dangerous to me.
Well, you don't, want to stick the soldering iron directly onto your fingertip. Obviously, that'd be bad.
I'm very clumsy.
You just make it long enough so that, and then you could just kind of, slip that thing off and just put it down.
It's a pretty sweet ring you got there.
Yeah, it's just, you make like a solder ring out of it. Okay, so I guess we need to, try to solder something. Right? Okay. Alright, so jumping back to the soldering iron temperature thing. The solder will melt somewhere around 380. Or 371, I think, if it's the 6337 solder. If you're soldering heavy duty things, there's actually some battery holder posts that came with this kit. Here, Ken. So there's these kind of heavy duty, right? And this is a relatively large piece of metal that we're going to try to solder. So you might need to go up on your temperature just to make this thing hot. And not only that, but this is just a piece of metal, so you're not really that worried if you get it a little bit too hot, because, what's going to really happen to it? However, if you're soldering something like an IC, which we happen to have here, I'm not sure what this is like.
It's a 32. It's the 328p, isn't it? An Atmel 328p.
Yeah,
that's the microcontroller found in the Arduino Uno, and just kind of the very general purpose cheap 8-bit microcontroller.
Okay, but it is an Arduino.
Well, it could be or if you flash a bootloader. The code's already programmed to that, so we don't it's probably just AVRC flashed down to it.
Okay. Cool.
But in theory, you could take this microcontroller and reprogram it and use it for whatever you wanted.
So what I was looking at, wanting to look at instructions for, I didn't know if they said you had to put certain colors in certain places.
Probably.
They're not labeled.
Well, I guess as long as it was consistent, it'd be fine.
Yeah, I suppose. All right, a few quick notes on how to put stuff on a PCB. Oh, look, they're actually, watch the notch. All right, so they're kind of giving it away here. If you look, there is actually a notch on that edge of that IC. So that's good to know. They're saying, hey, here's where your notch goes. Also, pin 1 is to the left of that notch usually.
Yeah.
And the numbers, if there's numbers, it goes like counterclockwise around from that. So the notch is like the starting point. So I'm going to take this IC, stick it on that PCB, and this is where the masking tape comes in. So you get some masking tape, and you do that. That's simple.
Just so it doesn't fall off the board when you turn it upside down?
Yeah, because you're going to be soldering, you know, the place where you're supposed to solder, which is back there. And I'm going to use this, see if this third hand thing will cooperate properly with us. And if we can get it on the camera on a good angle. I kind of want like a slightly side angle. I mean, I guess that's good.
Yeah, that looks pretty good.
It's going to be really tricky to also try to look through that at the same time. Let me see if I can find an angle where we can do both at the same time. Maybe. Well, how about this? I'll set this up so that the camera looks through it, and I will just look at it without the magnifier. I think that's just going to have to be the way that we do it. All right, Ken, can you... I need the thing right next to the laptop there.
What?
Those portable magnifying glasses things that... Yeah, those things. I had a feeling I might need them.
Old man.
Yep, I'm an old man. I cannot look at things without a light and a magnification. All right, I'm going to set this thing to non-obscene temperature. Exit. Okay. I'm going to go for 400.
The chat's right. We should have just strapped a GoPro to your head.
Yeah, we could have. Separate thing you're going to need when you're trying to solder is either a damp paper towel, and by damp I mean almost like saturated, or a sponge, also almost like saturated. This helps you clean the soldering iron tip, and if you're using rosin core solder, once you've done that, it helps to re-tin the tip. And actually this tip kind of cooled back off because I just put it on something moist. So use rosin core solder. Feel free to get like a whole bunch of the solder onto the tip. You're going to clean it back off. But the reason you're trying to do this is to get the rosin that's in the solder to try to clean the metal. And then you can see like that paper towel looks a little worse now because it just cleaned off the soldering iron tip. All right, let's get this thing back in the frame. Now, I don't think we're going to have this thing fully assembled on this stream because, well, you know, I don't know if we could do that much stuff this quickly. All right. Can you still see, Ken? I can't tell where you guys are versus... All right. So now when you're actually going to solder something, you need some solder on the soldering iron tip before you do anything. And the reason is that if a soldering iron tip has absolutely nothing that's liquid on it, then you are going to have very little surface area. Actually, I need to up the temperature a little bit. You're going to have very little surface area between the tip and the thing that you're trying to heat up. So you put Nah, that might even be too much. Alright. Little bit of solder. Now that liquid solder that's on there is going to help conduct heat to the pad and to the pin that we're going to solder. And the thing is, you want to come at this at like a 45-degree angle. You want to get both things to the temperature that's going to melt the solder before you put the solder on it.
Yeah, because when I watch most people try to solder, they like put the solder in there and like try to paint with it, and they don't understand that you have to have both objects hot and then it wicks to it. You're not applying it. It's
You can
it's a heat-based thing.
Once everything is hot, you can effectively paint with the solder, but you can't just like go at it first and definitely don't take a bunch of solder, put it on the tip of the soldering iron, and then try to like paint the solder joint with the hot soldering iron. That's even worse because solder. You ever notice how like grease in a pan like wicks itself towards the hot part of the pan? Like, the same applies here, right? So that means that you're basically going to get everything hot from this side, and then you're going to come in, and you might need to actually come in and tap the joint area and the tip of the soldering iron just to kind of get a little bit more liquid solder in there. There we go. So now it's started. Now, I don't have enough heat. Hold on. Oh, and actually this soldering iron tip was a little loose. Okay. All right. So you get enough in there. And I need to look at it through the thing real quick. Actually, how does that look?
It wicked on there.
Okay.
Yeah.
Actually, I have almost not enough. What you want is a concave. Basically, you want from the solder pad to the pin that's coming through, you want it to be concave slightly. You don't want it to be a ball. See, now that I actually didn't do right, but it worked. Okay, so you get everything hot, a little bit of solder, get it going. Now add just enough solder, do what you want. And usually when I pull the soldering iron away, I usually run it up the pin that's coming out.
Oh, okay. Yeah.
That way, you know, and I don't have that issue here that much because my temperature is good and everything. But like if your soldering iron just isn't getting hot enough because it's maybe a cheap one, or you just don't have like a powerful enough soldering iron, if you see like a little a little bit of solder just like sticking out of the solder joint where you tried to pull the tip away, because it's going to try to follow the heat, right? And this applies especially if you're using like 60-40 solder, which might be in the plastic region while you're actually soldering it. You don't want it to be, but it might be. Come on. And notice that these solder joints are coming out shiny. That's how they should come out.
Okay.
Okay. The two things that'll make them not shiny is, the first one is that plastic deformation thing, like it moved while the solder was cooling back down. Number two is the worst thing, and that is you overheated the solder and it started separating. So the more you work with solder in its hot state, especially for the cheaper solder, where it might not be the perfect ratio, the perfect 63-37 ratio, it'll start to break down on you.
And I assume not conduct anymore, really. Or be a poor conductor.
It'll just be like, well, the worst issue than that is the brittle. It might conduct, but, you know. The other thing to look for, like if your solder is not getting hot enough, I'm using rosin core solder. So that's solder that has rosin in the center of it. And you can actually tell on some of these joints, I'm not sure if it's coming through on the stream, but especially the last two I did, you can see the rosin on top of the solder joint.
Yeah,
I don't know if you can kind of make it out.
Difficult to see.
But it has like a little bit of
a yellow tint.
Yeah, a little bit of like a yellowish, like kind of amber tint to it. Now that cleans off with alcohol, and you definitely need to clean it off with alcohol because rosin is an acid. If you leave it there a few years from now, you might not have a solder joint anymore. So, first of all, while you're doing the soldering, you'll see that rosin, some of it might enter the joint and might bubble up. So if you see that happening, you need to leave the heat on until all of the rosin has made it to the surface. Otherwise, it'll eat the soldering joint from the inside out over time. Right. So those are kind of like little weird things you need to look out for. And if you stop long enough to talk like that, chances are your soldering iron tip has started to corrode because it is a piece of hot metal. So we'll retin that.
So someone's asking in the chat, why aren't you using flux in this situation?
I am not using flux because I have, first of all, these are brand new parts. Everything's like, this is a silver coated PCB, right? Silver, chances are you don't need to prep with flux, especially if you just open the package and everything's all nice and shiny. And the component too, like the leads on this IC were very clean.
Okay.
So no need to do that. And part B is I'm using rosin core solder, which is actually acid etching that metal as the solder is flowing onto it, right? If you're using silver solder or you're using any kind of solder that's not a rosin core, which if you get into like really delicate electronics work, people will end up like not using rosin core solder because they don't want to risk like those kinds of issues.
Yeah.
See, this is what happens when you have solder. So what initially happened there, I don't know if you caught it if you could tell, but what initially happened is
it was balling up on the tip.
It balled up on the tip, and it did not want to flow into the joint because the hottest point of everything was still the tip. So the best thing to do in that case is you just like keep the heat on it, make sure it's, you might twist the soldering iron tip just a little bit, just to make sure you're getting good contact and
good contact with both the pin and the pad.
Yeah, you're supposed to be contacting both.
Okay.
Like I'm just stopping, I'm coming in at a 45-degree angle, and I'm just letting either the pin ride down towards the pad or ride across until it hits the pin. See, there's a hole. Okay. So there, I don't know if I can get this on this video. This, I intentionally stopped short. See how there's a hole?
Yeah, you can see a hole right there in the middle where the pin is.
Yeah, like this. It is soldered, but I didn't get solder everywhere I was supposed to get it. Right? That's like a bad thing. It'll hold, and I'm sure it would conduct and stuff like that. But that's not what your goal should be. Your goal should be to get enough solder there, and all you're really going to do here is just like reheat it, and then add more solder. And if you get like a really stubborn, a hole that does not want to close, then it is actually like something's dirty.
Okay.
Like, if you're just seeing that happen left and right, then that's what your issue probably is. All right, so
so why don't you speed up a bit and kind of get this microcontroller in there, then we'll move on to resistors and caps.
Yep, that's what I'm doing. I don't know if I'm running off of the screen or not.
Not really. You're good.
All right. Any other questions coming in the chat?
Not really.
Come on, guys. I know you got questions. Let me know if I need to reposition, Ken. Because I'm just going to rip through these.
Yeah, I mean, you're pretty good. So, okay. What do you do if you accidentally solder or bridge two of the pins, let's say? You get a little overzealous and...
Oh no.
bridge 2 of the pins on that microcontroller.
Actually, you know what's funny?
They're pretty far apart. It's difficult to do on this.
It's not only that, but since I was using the proper amount of solder already, it's like extremely hard to even bridge them. But if you did bridge them and you had your solder wick, as you should, and they sell this in different widths as well. And I do recommend if you're going to pick any of it up at all, you should pick up a couple of different widths. But you take like your narrowest width. Let's see if we're still.
Yeah.
So say those two guys were bridged together, you would take your narrowest width, you would lay it right in the middle, and then you heat up. And you always come down from the top, and the thing is you need to heat up this wicking enough to also heat up the wicking and the joint.
So you have to kind of leave it on there for a while.
Yep. And sometimes you've already saturated the wick and you need to like shift it over. And actually, did I just like desolder one of those joints?
I think you might have.
I probably did. But if there was solder there, then it would definitely be gone just by doing that. Since I mean, you can even see what I sucked up there.
Yeah, it's nice and shiny.
Yeah, it actually picked up solder in there. And if you wanted to desolder something, you would need to keep doing that with clean sections of wicking. A section of wicking that is solder colored is not going to suck up any more solder. Simple as that. I'm just going to redo these two joints. And then I'll just start holing butt on these.
So people are asking about stuff like ventilation, which is a good idea. You should do this in a well-ventilated area. A charcoal filter vent fan is a good idea for this sort of stuff.
Which we have one of.
We actually have one, but we have the front door open also.
And a fan in the middle of his microphone wouldn't be the best. It's a loud thing.
Yeah, that's true. And I mean, we're in a pretty big room here.
Yeah, but if you're doing this in like in your small garage or something like that, make sure ventilation is a thing. You don't exactly want to be breathing in these fumes.
So I'm not like, some of these are not the right amount, but I'm trying to do this soldering. I'm actually soldering not looking through this thing, through the magnifier. I'm kind of like working around the magnifier so that you guys on the stream can see it. But what you want is basically you want it to look like a TP, but a slightly bowed in one. Basically, you don't want the edges of that solder like where it's tapering off. You don't want it to be a straight line. If it's a straight line, you're basically borderline too much solder, right? You want it to like be a concave, like a curve in, which I can't show with my finger in front of this thing because it doesn't work. All right, so we've got an IC on there. So IC's on, take the tape off. It's masking tape. You can like re-stick it to all sorts of stuff plenty of times, more than likely. What are we doing next?
Let's do
LED?
resistors.
Oh, resistors. All right, let's find the resistors that they gave us. So let's see, I'm looking at the PCB here, and I've got a few spots, if I can line it up. So those are where the resistors would go, 330 ohms. And then there is, looks like 100 ohms, where'd it go? 100 ohms down there. So there's only, I think there's only 4. Nope, there's 5. Where's the 5th one go? Up there. There's a 10K.
Yeah, that would make sense for the microcontroller.
All right, and then I got some resistors here. And, well, guess what? There's 3 of this type. So we could probably cheat.
And assume those are 330 ohms.
We'll assume those are the 330s. Now, I'm trying to be, can you even make out the...
Yeah, not really. A little bit.
Can't really make out the color codes.
Yeah, so resistors are color coded. There are 4 lines, 5 lines. Is it 4 or 5 on a resistor?
There's 5 if they have a percent rating.
Okay. So they're...
Oh, wait, 4. Sorry.
They're color coded, and there's a decoder you can use. The SparkFun guide will teach you how to figure the right resistor. We're just going to teach you how to solder it. So consult that guide for what resistor you need to put where. This is kind of more of a universal thing that applies to anything you're soldering.
And there are dirty old man mnemonics for remembering the color codes. I actually have one going through my head right now. Okay, so here's one of our 330 resistors. You want to get it on that PCB. All right. I don't know if I can show this through this thing. They make a tool for this. It's kind of expensive. If you happen to have a micrometer, and you don't need to use it for measurements necessarily, you just need to use it to measure between the holes on the PCB, if I can get this in the right place to show you. So I'm just gonna like, you know, kind of like rough measure this. And this actually usually works out perfect if you're like towards the inner sections of the holes if you're using this kind of a micrometer. And then you flip to the other side of the micrometer. That's not gonna work with this one. Well, it might. I'll try. So you might be able to take this, lay the resistor in there, and then bend the leads. I don't know how well that's going to translate on the camera.
Hey, you can see it.
But if you bend the leads, now you've just, hopefully, you've hopefully made this guy able to drop right in.
There you go.
Like so. And then, take out your masking tape. There's several reasons we're doing this, but you want to make sure the resistor is kind of centered there. Hold it in place with the masking tape. Then you're going to spin the guy around. Now, here's something that is a mistake that's a common thing. Do not solder this like this and then cut the leads. Do you know why?
Not in particular. It seems like it'd be more difficult that way.
It does make it more of a pain in the butt. I will grant you that. And by the way, if you're using like angle cutters like this, they have a little bit of bevel to them, which actually ends up giving you most of the spacing that you need, like the height that you need. What?
He was just making fun of your old man reading glasses.
Of course, he's making fun of my old man reading glasses. All right, we cut this first. I'm trying to get the stupid thing to show up. Now, I don't know if you can tell, but can you see that the center of those pins is not the same color as the outer part of the pins?
No, you can't.
Okay. These are silver-coated copper.
Oh.
Okay. All those leads you see on resistors and diodes and whatnot, there's copper in the middle, and they're silver-coated. Copper rusts and like turns green and stuff, right? Do you really want bare copper hanging out?
Probably not.
On the bottom of your PCB.
I don't think so.
You don't.
That sounds like a bad idea.
Okay, so what you do is you make sure, so not only do you have you cut this first, but you make it a point that when you're soldering this guy, do we got the whole joint on the thing? You make it a point when you're soldering that one of the times that you touch the joint with your solder, you touch the top.
Just to give it a nice coat over so there's no exposed copper.
Yep, so then you have just tinned the copper.
I never knew that.
And that's it for that guy.
Right. So why don't we move over to one of the other components on this board?
Yeah.
There's some capacitors, there's some diodes.
Let's see. Capacitor. Yep, there's a capacitor. I got a couple of them. They look like they're the same. They're the same rating. So let's find a spot up here where a capacitor is going to go. Actually, that's a good question. Oh, there we go. 0.1 microfarad. And I'm going to guess, since these are the only ones that came in the kit, that guy is 0.1 microfarad capacitor. Same deal as the resistor. We luck out on this. We don't have to do any funky bending of leads or anything like that. And notice I'm just reusing the same piece of masking tape. Like, you don't really need to blow through masking tape to do this stuff. Alright, so, again, pins are too long. And for this, you're only really going for a long enough lead. Like 1/8 of an inch is almost too much here.
You just want enough for it to barely stick out of the end of the hole.
Well, no, you wanted enough for it. It needs to stick up enough for you to have a proper concave ramp of the solder.
So if you,
right?
if you kind of, in this case, if you put the microcontroller through the holes and look at about how much that is, that's like how much those pins are exposed is about what you're going
Yeah,
for.
those tend to be like, they might be a little bit on the long side.
Yeah.
But for those, you weren't clipping them.
Yeah.
So they're silver coated all the way to the tip, right? But these you are, so.
Someone's scolding you for putting the resistor in backwards.
It's only in backwards if I don't line them all up the same way.
Well, okay, so they're not polarized, but if you want to read them later, you should probably put the color codes in the right order.
Yeah.
That's good practice.
Did I put that in? No, I got gold on the right.
Okay. I didn't see it.
Yeah, there's gold is on the right. So if you were trying to read it like left to right, then we're good. Pull this masking tape off. And speaking of polarity, so here is an LED. Which one's the positive?
The longer leg.
You're right. Okay.
I'm a smart guy.
Now here is another LED.
Mm-hmm.
This one's kind of jumbo. And I don't know if you're going to be able to tell on this. Does it have a flat spot, actually? Wait.
I don't know.
Oh, these don't have flat spots on them.
Yeah.
Dang it. So we can't use that as, let me see, maybe one of the other ones does? Nope. So usually round LEDs, and it's pretty funny because on the PCB, they actually have the flat spot. So the flat spot is where the minus is. And to remember that, it's just like the flat spot kind of looks like a minus.
Yeah.
So it's like the minus. And then like the positive is always the longer one, because if you think about it, like if you take the extra line from the little plus and add it to the thing in length, like then it would be longer, right? It's kind of a cheesy way to remember it, but you know. What should we put on next?
Oh, let's go ahead and put an LED on.
Okey-doke. They didn't tell us what color to put where. So, heck, I don't know. We'll just go for this one. Blue on the left. Or pick a color. You pick a color.
Just go with blue.
Okay, fine. Red, no blue.
Ah!
If you didn't get that joke, I don't know.
We've got some movies to watch.
I don't know what you're doing here on the stream. Also, resistors sometimes will have... these are actually like soldered.
Okay.
Or they're either soldered or like more like heat welded or whatever the heck you want to call it, like at the factory. So they see those two little flat spots right there at the at the bottom. I don't know if it's coming across on the camera.
Yeah, you can see them.
Sometimes they come that way, and sometimes those sections do not want to go into the hole. You end up with something like this. You just gotta push harder.
So, like, is there any particular reason for that? Like,
they just don't. Some of them just don't get manufactured with the full length of the lead on them.
Yeah.
And then another part in the assembly process, they'll just like tack that on.
Okay, I pulled up the picture. You're on the left side.
Yeah.
That should be a yellow. Just because.
Oh, fine.
You know, we got to make it to spec.
Okay. Yes.
It's important.
Well, it's like a Simon Says game, so it's like if it does yellow.
Yeah. Yeah.
You know, and it's as long as you tilt it in the same direction.
To detail.
Yes, I do.
OCD.
Ken he's a stickler.
And you're supposed to bend them 90 degrees.
Oh, they want it. Wait.
Yeah.
What?
Yeah, it's supposed to be at a 90-degree angle.
They want it hanging off the edge of the board.
Mm-hmm. Because you're tilting it to that direction. So that'll be a good thing to show how you bend a...
Well, for something like this, I would cheat.
Okay. Well, that's a helpful tip.
So I'm just like, see, I kind of want it to be bent, and I'm just eyeballing the length here.
Yeah.
And then I'm just gonna like kind of bend it.
Just kind of make the bend and then cut your legs to length.
And you can't see it, but behind the PCB, my fingers are pushing the leads to make a full 90 degree. Mm-hmm. Because you want the leads to be sticking out.
Yeah, you don't exactly want to break it off.
Yeah.
That would be bad.
No, that would be bad. And then this is going to be a little tricky. You don't want the masking tape on the leads.
Well, since it's bent, it should mostly stay in there.
Yeah, I'm just kind of holding it in the right place. All right, so little side note here. If you were concerned, and we don't have something small enough to do this with, they actually make specialty tools. But if you were concerned about overheating the LED and like damaging it, they make things that are kind of like little alligator clips. They're narrower than this. They're like really narrow, and they don't even have teeth on them. They're just like straight, like flat aluminum. Almost looks like scissors or shears, except they just come flat together and don't have any kind of cutter on them. And what you do is you would like clamp those on to the lead as close to the LED as you can get it. Okay. You would do that if you were worried that the lead was going to carry too much heat into the LED and damage it. But the thing is, like, you can't put it too close to where you're trying to solder because it's a heatsink. So it might make it very difficult. All right, let me spin this guy around.
Oh man, our 3D print is done.
Uh-oh. Well, you can't let people guess now. They'll just like...
Well, we can until we cut to it.
Well, oh yeah. But, the last it was on the stream, it looked like an orange ball. And our masking tape is not really doing its job that well, but hey. Where are the cutters? Oh yeah, try not to like shoot your eye out, kid, when you're cutting these things. If you notice, I kind of like have a habit of just like holding on to the lead that I'm cutting as I'm cutting it. If I can get a good grip on the cutters, that is. Dang it. What's up with that? All right. Grab my solder.
There's another one of those in there if you want it. Sure. Or if you want something else. Don't matter.
Take our tape off. All right, and this is actually a good, if you can see, you can see that the solder had wicked slightly up the lead on the other side.
Through the hole.
Yeah, so I mean, it doesn't have to, because there's not solder pads up here. Mm-hmm. Solder pads are only back here. Yeah. But that's basically like the right amount of solder, right? You don't want so much that it's dripping out the other end of it. Like, that'd be kind of silly. Yeah. That sort of thing.
So why don't we go ahead and show the battery holder? That's kind of the rest are just diodes, which are like LEDs.
Yeah,
and
we'll just do a battery holder.
Are completely easy, and so we'll show the last sort of unique component in the battery holder, and because since that's metal, it has different properties.
It is. It's going to be more of a pain. And I need to see how. Oh, wow! These are. Let's show that on here.
The beefy.
So they made it in such a way. Oh, hold on. Let's get our position right here. They made it in such a way that it actually clips into the hole. And like.
Because you really want to make sure that's flush, or else your battery won't sit right.
Yeah.
You want to make sure both of them are completely flush with the board.
Yeah, and this is a pretty cool design on on those, so that the part that's actually going to make the electrical contact to the PCB, at least on one pin, judging by what that looks like the bottom pin is the thing that's going to make the contact. But what you got to realize is this is like one big heatsink.
Yeah.
Right? Like it's basically, a huge surface area. So it's going to be kind of a challenge to get this to heat up in the first place. So I might have to actually crank up the heat on the soldering iron.
So we're talking like 10 degrees here, or like roughly about how much?
So since I have only been putting the soldering iron on these components very briefly, I've got this thing regulating at 500 degrees right now.
Okay.
If you were doing
Which is very high.
That's high, but because you see I'm only on each joint for like maybe 4 or 5 seconds.
Mm-hmm.
So this might work with this current heat, but I might just have to like stay on it for longer. So notice I'm making dang sure that I have a solder bridge to try to conduct heat into this thing.
What do you mean by that? You had solder on the tip?
I had solder on a little bit of solder on the tip, and I'm actually watching it move around on the pad.
Okay.
But it's not moving around or wicking onto this connector yet. So I'm going to try to put a little bit more on here and go right for the connector. See if I can get it to heat up enough. We might be good enough here. Maybe.
It's wicking a little bit there.
It's hard to tell.
Yeah, it looks like it's wicking a tiny bit.
There we go. I think we just hit the point.
There you go. Ah, beautiful.
So see, I had a little bit of a hole on the top. I kind of painted it.
So does it just have to heat up more, Alan?
Yep. You just got to give it more time. You wouldn't think that like that big old heatsink kind of thing and this really tiny soldering iron tip would actually be able to heat it up that much, but you just, with more time, it'll do it.
And it is at 500 degrees Fahrenheit.
Well, yeah. But you also have to have like this bridge of solder actually like helping it conduct heat.
Yeah.
Giving it more surface area. So I'm going to try to fill this hole in back here. Now I actually have to like bring the tip around to the back to even manage to fill this guy in here. But you pretty much know you're at the right temperature. If you can apply solder from the far end of where you have the soldering iron on the opposite end, and it still liquefies it and still melts it and adds to the solder joint, then you're hot enough.
Okay.
Pretty much.
Cool. Well, those are the basics of through-hole soldering.
Yeah.
Are there any SMT pieces for that PCB? I'd be kind of interested to see how you would actually mount that.
I don't know.
With solder.
Is there any SMT on there, Alan?
No,
Surface mount? No,
there's
not this one.
There's none on that.
What? Okay, just quickly explain, if Alan can, how you would do that. Just explain.
Briefly explain how you would solder surface mount stuff.
Very careful.
Extremely carefully. So, so
But they have these giant wave pools that do them for them.
You get it lined up perfectly, masking tape, and then you really only need to tack like a couple of opposing pins down.
At what point are you going to teach like BGM solder flow?
Yeah, BGA.
Now I did.
No,
you have something
BGA.
with SMT on it?
Alan can't do BGA.
Even one that I
How
can just
do they do
show and just,
BGA?
like, hit
I want to know. I
soldering
mean, do
iron
they
briefly?
heat up the PCB and then just slap the BGA on top of that?
I have no clue how BGA
Put it through a
works.
river of solder.
VGA? Yeah, you do.
It's like making a motherboard.
Yeah.
Is it really the waves? Is it the wave solder system over to get a BGA in there?
So, actually,
Talk to me.
Very small
hold on.
packages.
I gotta make that so
What are we
that
doing?
so that we can show.
Those are 0805 packages, I think, on the resistors and
So
capacitors.
this is actually Ken's video switcher
Ooh.
with the buttons.
Well, one that doesn't work.
This one doesn't work. Aww.
Yeah, that was the first prototype. Remember that one?
Oh,
Yeah.
yeah, I do remember that one. That one ended badly.
Yeah.
So, I mean, you basically just need to be extremely careful, and you need to. So, you can use this tip, but you probably want to flip it upside down. So the point is actually like towards the PCB, and you kind of want to come in
Oh, no, there we go.
on the edge
Did it black
because
out again?
you still want to be able to touch the solder pad as best you can and the pin at the same time.
Huh.
So you basically need to come in like at a very sharp angle with just the point touching, and I don't know if that's showing at all.
And not
Start
really.
up Dirt Rally and see
So
if you
there you
can get
go.
the wheel
Like,
to work.
I'm probably frying the crap out of this chip right now.
Sometimes.
That's only an $8 microcontroller.
So you would do that, and you would also use either silver solder or 6337 solder that is not
know if I have
rosin
the
core
Logitech
because it
silver.
comes narrower. It's like a much thinner solder. Because you cannot, I mean, look at this.
I mean, that's
like
exactly what we soldered that board with.
Yeah, but like, here's the solder I'm using compared to that,
Yeah.
and even that is pushing it. Now, I managed to do it with this.
As
but
have I. It's
but
not
you're-
fun.
and this is actually pretty fine solder, but you're really pushing it
Yeah.
with that, and you're just asking to bridge pins together.
Yeah, so, like, if you show one of those resistors, that's a...
Oh yeah, these were a pain in the butt too.
Yeah, it's an 0805 package, which is... Let me look
Yes,
up
those were the
exact-
ones I was really thinking of. It would be hard to do because I've attempted, in the past, way back, the 9500 Pro
And we
to
did not use any kind of
9700 Pro
masking tape or
mod.
anything to hold these
Yeah.
resistors down, which is why the solder
Yeah.
joints look like crap.
Alan
Yeah.
can't hear you, by the way, Josh. That's why he's talking.
Oh,
Yeah.
Oh,
That's all right.
yeah, I can't hear Josh.
Yeah, so 0805 is 2 millimeter by 1.25 millimeter.
Yeah.
well, ask Alan
That's
if
the
he
size
ever
we're dealing
tried the
with.
9500, 9700
definitely
Pro
up there.
mod.
Oh no.
Alan,
Josh
did you ever-
wants to know if you ever tried the 9500, 9700 Pro mod, where you had to do a surface mount resistor. Or take one off, I guess it was. Put one
You
on.
moved
Never
it.
did that.
You
but
moved it. You moved
I,
the resistor.
I have done plenty of like PS3 mods.
Oh,
which is
the
where you
PS3
have to,
mods,
which
yeah.
is where you have to tack a bunch of there's surface mount components on the PS3, which are basically this pitch
Yeah.
of pins.
It's a JTAG, isn't
Yeah,
it?
try
On the
that.
PS3?
A couple of them as JTAG, but no, some of them you have to go directly onto these pins. Like you have to tack wires onto those pins that are also, and not bridge stuff with solder.
Yeah.
Well, we got the best equipment there for you, Alan.
Yeah, so we should just start going into business modifying PS3.
Let's not.
Seems legit.
All right,
yeah.
so Alan's going to continue working on that. We're going to show a little bit of dirt rally racing here. All right, switch to Alan.
See if this piece of junk works.
All right, Josh.
Oh, you got to go to the other camera.
Thank you, guys.
Thanks for racing.
All right, let's.
You
push
feel
some
free to,
stuff out
if
of
you
the
want to, you
way.
can call in later with us from the
Put this
11
thing
to
up in
12
the
hour when we
air.
play Risk. If you just want to chat,
Sure.
yeah, I'll
sounds
hit
good.
you up in hip chat if you're around.
we'll call you. Bye.
I'll miss you, Josh.
So we got Simon
Bye-bye.
Tilts.
He can't hear me.
See you guys. No, he can hear you. You can't hear him.
Oh, okay.
And what's cool is that they made their own tilt sensors, and all they are is steel ball bearings inside of a little plastic tube with an IR emitter and a detector on either side.
Huh. That's pretty
And
cool.
they put them on 3 different 45-degree angles.
Yeah. So it's unique.
So yeah.
So turn on the sound as well and turn on the power.
Yeah. All right, so you turn it on, and then it's supposed to you're supposed to tilt it somewhere to wake it up or tell it you ready to start. So, no. Interesting.
Don't screw it up. Oh,
That's a pretty cool learn to solder project. Like, it's something you'd keep on your desk and mess around with every once in a while instead
Yeah.
of like a stupid smiley face or something like that. You won!
Did I?
I think that's what that means.
Oh, this bottom one too. I assume the program isn't that extensive, so it just quits up to like 4.
I guess.
If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.